Hello students, we now will discuss high-tech places to work. This is the first part of that presentation, and we look at office buildings, institutional buildings designed with high-tech architecture. Just to give you a glimpse again of the evolution of high-tech architecture, let's go back to the origins 1971 to 75, the Reliance Controls factory by Team 4, Foster and Rogers, a prototype of high-tech factory logic. Centre Pompidou, Paris, 1977, Richard Rogers, Renzo Piano, classic high-tech with all exposed services and structure on the outside, and the building is completely free and open on the inside. The raw machine aesthetic of the 1980s with the 82 NMOS microprocessor center by Richard Rogers, and it was a lightweight tensile roof modular high-tech factory. 85 Aachen medical facility looked like an oil refinery rather than a healthcare facility with extreme inside out mechanism or bovilism. 86 Lloyds of London services structure on the outside, lifts exposed, radical inside out corporate building. HSBC 1986 Norman Foster, suspended floors, modular services, transparent atrium. Then in 1990s, towards refinement, Stansted Airport by Norman Foster, lattice work of lightweight roof, modular piers and a clarity in passenger flows. We will be looking at it when we will look at our presentations on airports. Then we have the 97 Commerzbank in Frankfurt, which was the first ecological skyscraper, an ecotech pioneer with natural ventilation and sky gardens. We will talk about it in this presentation. Then we have the Reichstag Dome in Berlin in 1999 by Norman Foster, transparency as democracy, layering made symbolic. We will also have a glimpse of this building in this presentation. In the 2000s, civic and corporate maturity came in 2001 with the 88 Wood Street building by Rogers, refined corporate high-tech with a glass facade, service cores at the edges but within the glass. Millennium Dome 2000, we talked about it last time, Rogers tensile megastructure, a technological optimism. In 2000 by Sendai 1 to Sendai Mediatek in Japan by Toyo Ito, digital high-tech with structural tubes mechanism. We had seen this many lectures back, we will probably have a look at it again in more detail. In the 2000 civic and corporate maturity, 2006 the Barrages Airport Terminal in Madrid by Richard Rogers with these color graded columns that I showed you, which are for wayfinding and for high-tech aesthetics. We will be seeing 2006 Hearst Tower in our later presentations, again by Foster, having a Diagrid glass tower and a corporate sustainability. The Welsh Parliament 2006 by Richard Rogers, transparent democracy, again like the Reichstag. The roof is where the public can participate in the parliament session. The evolution of high-tech architecture in the 2010s, smart tech and environmental high-tech. The Centre Pompidou Metz in France by Shigeru Ban and Jean Nouvel, a cultural high-tech with timber and color accents in 2010. 2013, the Shenzhen Baoan Airport in China by Fuxas, honeycomb tensile shell, a monumental scale. And then we have the Edge in 2014 in Amsterdam by PLP Architecture, smart workplace, IoT integration, Internet of Things, and the greenest office, it is what it is known as. Then in 2010s we have the Apple Park in 2017 by Norman Foster, corporate high-tech with solar energy. 2017 the Bloomsbury Headquarters, which we will be looking at later, by Norman Foster, the most sustainable office today. Thus for high-tech buildings, Phase 1, 70s to 80s, raw exposed high-tech, Pompidou, HSBC. Phase 2, 90s, refined corporate civic maturity, Wood Street, Reichstag. Phase 3, 2000s, expansions into civic and cultural mega structures like the Millennium Dome, O2 Arena, Barrages Airport and the Senedd or the Welsh Parliament. Phase 4, 2000 to 10s, digital offshoots like the Sendai Mediatek, sustainable smart tech like the Edge, the Apple Park and the Bloomberg HQ. Thus we have in summary the progression of the high-tech architecture movement. Coming back to the 1970s, the Willis Faber Dumas Headquarters in England by Norman Foster, the country headquarters of this insurance company, which challenged the accepted thinking about office buildings while maintaining a sense of continuity with its urban setting. It has got this very dark glass curtain wall with curved corners. The building just curves along its edges, along its side edges, and its sleek modern sculptural form, pioneering example of a deep plan, an insulating green roof or grass roof, a energy conscious design which ensures good overall thermal performance. The floor is planned on a flexible 14-meter square structural grid with most of the columns on the periphery like a necklace, and here the building just spreads out like it on the site as a pancake spreads on a pan, and it goes along the sight lines which are not at all in perfect shape, completely asymmetrical. This open plan office floors pioneered flexibility and adaptability in workplace design. These are the plans, the isometric, the section perspective, and fitting the building in the urban context was important. On the outside, the building reinforces rather than confronts the urban scape around it. It is low rise with a free form plan and responds to the scale of the adjoining buildings. Its curved facade maintains its relationship with the medieval street pattern, which was not orthogonal, it was curvilinear, and by day the glass reflects a collage of surrounding older buildings, and by night it opens up to show itself. The transparency of the facade represents openness, which is a complete break from the heavy stone clad corporate offices that were common in that day. Now, pushing the limits of technology, it has got this glass which is completely mullion free. It is suspended by this clamping on the roof, and the curtain wall is hanging independently. The corner patch fittings connect the panes. These corner patch fittings, they connect the panes together, and there are these internal glass fins here that help to keep the glass steady against the wind. There is an unprecedented use of escalators that come down 3 stories in this building. The large suspended floor plates are there over a waffle slab. You can see this in detail. This is in the section, this is the waffle slab, and the roof slabs are over it. And because there are minimum internal columns, the open workspace is maximized. At the top here, there is a truss, and on top of the truss there are the services of the building. Thus the services are on the outside, and inside the space is completely clear for the work areas, and there are also skylights provided in the truss that pulls in light into this large central atrium. They also pioneered the use of raised office floors, expecting an IT revolution. When extensive computerization was introduced, they were able to change those lines etc. with minimal disruption because they had the needed space to bring about that modification. Paradoxically, though it is designed for flexibility, it has since been given grade 1 listed status, which means it cannot be changed. The employees are it's an employee centered design with a roof garden, swimming pool, restaurant for the well-being of the staff, all conceived in a spirit of democratizing the workplace and creating a sense of community. Indoor and outdoor spaces seem to merge in the building. There is lightness and transparency. Now coming to the HSBC by Norman Foster, though we have seen it in bits and pieces, I will just put it together for you again. 180 meter high, 47 stories with 4 basement levels, kit of parts construction, prefabricated steel modules brought from abroad, assembled on site, the high-tech principle again of flexibility and modularity, example of high-tech not in style but more in technology. Its original design is heavily inspired by the Suncorp Place in Sydney by Jocelyn and Gilling in 1982. About 32,000 tons of steel, 4,500 tons of aluminium were used. Elevators only stop every few floors, and the floors are rather interconnected with each other through escalators. The floors are suspended from these giant steel masts that you see. There are 8 sets of these steel masts, and from these steel masts there are these 5 level of these coat hangers or these suspension trusses on which the floors are hanging, and they transfer, the trusses then transfer the load to the masts and into the ground. It creates a column free serviced interior, thus again an omniplaza. As a result of no interior supporting structure, there is an open plaza, as I told you earlier, at the ground level. Sea water is used as a coolant in the HVAC system instead of fresh water, and the flooring is made up of lightweight movable panels, something that he had also done in the Willis Faber Dumas building, under which there is a comprehensive network of these cables. The design is to allow equipment, computer terminals to be installed quickly and easily, as was possible in the Willis Faber Dumas. Notable feature is the natural light, which is the major source of lighting through a sun scoop which is on the outside. This is the sun scoop that you see here. From here, when the light falls on it, it bounces towards this reflector in the atrium of the building. An aluminium mirror is there, and this mirror then projects the light downwards into the building. And there are also sunshades to block direct sunlight throughout the building, and thus to reduce heat gain. But the only controversial part is that this light, which is thrown by the aluminium mirror into the atrium, actually did not turn out to be like natural light, but more like a metallic light. The construction relied heavily on off-site prefabrication. The site became like an assembly site. Components were manufactured all over the world and shipped to the site. The structural steel came from Britain, the glass, aluminum cladding and flooring from the US. The service modules I had shown you earlier also, the toilet modules for example, came completely ready from Japan. Then we come to the Commerzbank in Frankfurt, again by Norman Foster 1997, a true high-tech building, not in style but in technology, the world's first ecological skyscraper, 56 floors, 299 meters high, integrates climate responsive architectural principles with environmentally sustainable design strategies have been included in this building. Opposite to the the sealed, centrally climate controlled, air conditioned models that were prevalent at the time in America, this building is completely different. It has got sky gardens, about 9 to 10 sky gardens throughout the building in a spiral, which are buffers against heat. They provide natural cooling and improve the indoor air quality. The spiral arrangement brings in sunlight throughout the day depending on the orientation. So when you see this atrium here, or the sky garden here, there is a deep atrium in the center. All the rooms get natural light, whether from the atrium side or towards the outside of the building. I will show it to you in the plan. The 4-story sky garden is at different levels, and it's a spiral of landscaping around the building. Offices are grouped around these gardens in clusters of 3 to 4 floors. They are like stacked neighborhoods instead of being one monolithic office block. So there are these series of neighborhoods stacked one above the other with openings towards the garden for each set of floors. The garden has views, natural ventilation, and an informal interactive environment is available every 3 to 4 floors of the building. The daylighting, I had shown this slide earlier also, comes from the central atrium, natural light deep into the building, minimizing the need for artificial light. The facade is a triple skin facade which insulates the building and helps to adapt the temperature changes while maintaining the comfort inside the building. This is the plan. The plan is in the form of the company logo. It is a petal and stem design, triangular, having 3 petals like this. In 2 of them there are the offices. The third one has the sky garden. Inside, in between them, is the full height central atrium, and there are these pair of vertical masts at every corner which enclose the serviced and circulation cores in the corners of the plan. Thus the high-tech concept. The services are on the periphery and there are these open plan interiors. The masts support 8-story virindal frames which in turn support these clear span office floors without any column in between. What are the virindal frames? This picture is an example. A Vyrendal frame does not have diagonal members, and as a result of only having vertical and horizontal members, it is very clear and open aesthetic. And because of this elegant aesthetic, it has been used in this building, not only in this. In this particular slide, you see earlier than this building, it was used in 1989 by Raj Rewal. He used Vyrendal frames in the STC building in New Delhi. These are the floors which are being carried by the Vyrendal frames. These are the atriums of the building, the sky gardens, the atriums. Now the Commerzbank at night has got a yellow lighting scheme, and it has become important to have exterior lighting in contemporary tall office buildings. So whether it is Commerzbank, HSBC, Bank of China, Lloyds of London, all of them have got light to make them aesthetically pleasing at night. Now the Commerzbank is an early example of an intelligent building. Nearly all internal environment regulating systems are linked to one central computer, and thus this is the building management system of the building. The climate responsive operation is such that it is mixed mode. Whenever the natural ventilation is possible, it switches off the mechanical cooling or heating and runs it only when it is necessary. The windows are automatically openable automatically, and they are protected by outer glass. Whenever the conditions allow, the windows can be opened, and they are safe to be opened in high winds and even in striking rain also, and up to 25 to 30% less energy is consumed by this building as compared to a conventional building of the similar size. The sky gardens are also linked to the computer system. Thus we have energy efficiency. I will not read the whole slide through, but you can read it later. The aspects that are covered with this ecological skyscraper: energy efficiency with reduced reliance on air conditioning, daylighting through the sky gardens, the atriums and the triple glass facade. The material and environmental thinking: it has a low environmental impact. It has got green integration with the sky gardens, which reduce the building's environmental footprint. Therefore, it is a climate responsive design. It is a truly high tech building which prioritizes environmental sustainability when most all office buildings were sealed, mechanically cooled glass boxes. The next building is again by Norman Foster, 2004, St. Mary Axe, or the Gherkin, or the Swiss Re. It is commissioned by the Swiss Re company, the world's leading reinsurance companies. 43 meters high, 76 plus 1000 square meters of accommodation, including offices and a shopping arcade. This building is conceptually very similar to the Commerzbank. I have talked about this earlier. I am going in a little more detail now. It has got indoor sky gardens and atrium. It got a radial plan with a circular perimeter. It widens in profile as it rises and tapers towards the apex. It is also tapered towards the base. As a result of that, the open space at the ground level maximizes and turns into a public plaza. This is the plaza that you see here. It has got a double glazed facade which has got low reflectivity glass, and it improves both the visual comfort and the aesthetic of the building, and also provides energy efficiency and sustainability. It has got a diagonal frame or Diagrid frame, a diagonal grid frame that allows column free floor space on the inside, a fully glazed facade. It opens building to light and views, and it cuts down all internal supports. The prime method of controlling wind excited sways in buildings is normally either to increase the stiffness or to provide mass dampers to damp the building. But Ovarup in this building used the Diagrid structure itself to make the building stiff without any extra reinforcements, and despite the overall curved glass shape, there is only one piece of curved glass used in this building, and that is this cap provided at the top of the building. It is an environmentally sustainable skyscraper. Its round shape reduces wind deflections and external pressure differences. If you compare it to a cuboidal block, you can see how the wind just flows around it from between the windward and the leeward side, and which draws air across the building, and the shafts channel the air upward and downward. Therefore, the double glass panels act as a double giant double glazing effect. It's a thermal buffer between the exterior and the interior. It's air sandwiched in between that increases passive indoor thermal comfort, and the atrium dispels most of the heat energy that comes in, dispels it through this glass envelope. The building management system, it also has a building management system similar to the Commerzbank, leading to 50% energy savings as compared to a similar sized conventional building. The floor plate has a circular perimeter with 6 triangular light courts, and as the building rises, the floor plates, the floor plan, it rotates with each successive floor, and a series of spiral atriums are created within the building. And as a result of this, also on the outside here, the windows are openable in the atriums. They are controlled like in the Commerzbank by the building management system to augment the air conditioning with natural ventilation. The atriums also have openable windows which act like the lungs of the building, similar to the Commerzbank. Every 6 floors there is a double height informal breakout space where people can come out and stand, and the windows which open up provide them both ventilation as well as natural light. So instead of sky gardens, these are informal breakout spaces provided in the atriums every 6 office floors. These are the atriums, and at the very top floor, the London's highest occupied floor is in the Swiss Re building. It's a club room with a 360-degree panoramic view of the city. It was inspired by, so in order to show you more buildings globally, I am adding these examples which were inspirations behind both the Commerzbank initially and even the Swiss Re building, so that your architectural vocabulary expands. So I am including these buildings also, like the Petrobras headquarters in Brazil, and this building made in 1973 has got suspended office floors around a central service core with open voids and gardens that are cut out into the tower, very similar to the concept of the Commerzbank. Then we have the National Commercial Bank in Jeddah by Skidmore, Owings and Merrill in 1983. It is a triangular building. It's a triangular building with open central atrium and these large voids cut out in the facade. In the exterior there are no windows on the exterior due to the extreme desert environment, and the voids, they bring in the natural light to the offices or bring in daylight into the central atrium. The base of each void there is a sky garden, a large terrace with greenery which gives the occupants a place for plants and vegetation. This is how in the atrium the natural light filters into the offices. And thus if we compare the Commerzbank with the Gherkin or the Swiss Re, both, this has got a central glass atrium, this has got a spiring atrium system, and this got 9 to 10 sky gardens which are planted with vegetation. This does not have that, but every 6 floors it has got 2 stories of informal communal spaces. There is natural ventilation, it's got a mixed mode system in which the system can shut off if there is ample natural ventilation available. The windows are openable, facade flaps in the sky gardens are managed by the building management system, and the garden channels the fresh air into the building. The double skin facade, so this has got a triple skin facade. Swiss Re has a double skin facade with openable panels, again a building management system that controls the airflow, and the windows that are in the atrium are controlled again by the BMS, and the atrium, the informal spaces support the cross ventilation. When it comes to the form and orientation, it is triangular in plan, the Commerzbank with a central atrium. This has got a tapered form, what you would call a kind of a circular form rising up like a cylinder, but that is tapering at the top, tapering at the bottom, and this has got a central atrium with these 4-story sky gardens. This has got atrium spaces with 2-story breakout spaces. This becomes the world's first ecological skyscraper, and the Swiss Re is the ecological high-tech icon of the 21st century. We will end here and we will then again begin with high-tech places to work in another series of few buildings so that we can get an idea how high-tech buildings moved away just from more of style towards much more of substance and technology in them. Thank you.